Is it okay? So this is the procedure for calculating the transmission parameters of any two-port network. Maybe complexity of the two-port network will increases, but the procedure remains same. What the steps we are following now, so same steps we have to follow, but some more complexity will be increased if the complexity of the two-port network is increases. So for any two-port network, if you want to calculate the transmission line parameters or ABCD parameters, so first try to calculate A and C parameters by making I2 equal to 0 or by making second port open. Okay, so after making the second port open, then calculate the V2, that is the voltage across the second port. After opening the second port, calculate the voltage across the second port. Now take the ratio between V1 and V2 for calculating the A, and take the ratio between I1 and V2 for calculating the C. Similarly, if we want to calculate the B and D parameters, then make V2 equal to 0 or second port is short circuited. If you make V2 equal to 0 by short circuiting the second port, then calculate the I2. So later, take the ratio between V1 and I2 for calculate the B with negative sign, and also calculate the ratio between I1 and I2 for calculate the D with negative sign. So this is the procedure for calculating the transmission line parameters or ABCD parameters of any two-port network. So just now, as I told in previously, so this is a simple circuit. Just I'm considered to demonstrate how we calculate the different two-port network parameters. But it's better if you practice more with a different type of two-port network parameters. So what are the parameters we are calculated till now? That means Z parameters or Y parameters or ABCD parameters. If the passive elements within the network, remain same. So those parameters are remain same for any two-port network. For particular two-port network, the passive elements of the network are same. Then the values of all the two-port network parameters will be constant. It will not change with respect to the input voltage or input current. Whatever may be the input voltage, whatever may be the input current, whatever may be the output voltage, whatever may be the output current. But two-port network parameter like Z parameter, Y parameter, ABCD parameter of the given two-port network are remain same or constant until and unless you are not changing any any passive element in the two-port network element. In two-port network. అంటే మీకు ఇచ్చిన two-port network లో ఉన్న passive elements, resistance, inductance, capacitance ని మీరు చేంజ్ చేయకపోతే whatever may be the input voltage, whatever may be the input current, the two-port network parameters remains constant. So the two-port network parameters will change only if you are trying to change the value of the passive elements incorporated in the two-port network. Two-port network లో ఉన్న passive elements మీరు చేంజ్ చేస్తేనే Z parameters కానీ Y parameters కానీ ఏ two-port network parameters అనేవి చేంజ్ అవుతుంటాయి. ఆ నెట్వర్క్ కి ఆ పారామీటర్స్ కాన్స్టెంట్, ఆ నెట్వర్క్ కి ఆ పాసివ్ ఎలిమెంట్స్ చేంజ్ చేయట్లేదు, అవి రిమైన్ సేమ్ కాన్స్టెంట్ గా ఉంటాయి అనుకుంటే, then the two-port network, for that two-port network, all the two-port network parameters are remain same. They were not changing with respect to the input voltage or input current. So what about change of the order? Right. And now we will move to the hybrid parameters now. So we will move to the hybrid parameters. One minute. Yeah, we will move to the hybrid parameters now. Right. This is the right. So now hybrid parameters, come to the hybrid parameters, or it is also called as a H parameters. So hybrid parameters will provide the relation between the input voltage of the first port and output voltage or output current on the input voltage at the first port and current at the second port in terms of the current at the first port and voltage at the second port. Hybrid parameters H11, H12, H21 and H22, these are the hybrid parameters which will provide the relation between the voltage at the input port and the current at the output port in terms of the current at the input port and the voltage at the output port. That means V1 equal to H11 into I1 plus H12 into V2 and I2 equal to H21 into I1 plus H22 into V2. So these two equations are required for us to calculate the hybrid parameters of any two-port network. So same procedure what we use to calculate the Z parameters or for Y parameters or either transmission parameters, same procedure we can use for calculate the hybrid parameters of the given two-port network. Now we will discuss Now we will discuss about how we calculate the hybrid parameters of the two-port network. First, we will derive. So these things you can easily at this moment you are capable to tell how we calculate H11, how we calculate H12, how we calculate H21, and how we calculate H22, because the same procedure we are adopted for all the Z parameters and Y parameters and ABCD parameters. Now, first I want to calculate, if I want to calculate H11 and if I want to calculate H21, so what I have to do first? So if I want to calculate
Short circuit we
yeah,
have.
H11, if you want to calculate H21, make
V2 is equals to 0.
equal to 0. So that means you have to short circuit. You have to short circuit the second port. You have to short circuit the second port. You have to short circuit the second port. V2 equal to 0. And if you make the V2 equal to 0, or if you make the V2 equal to 0, if you make the V2 equal to 0 in the 19th equation, then we have V1 equal to H11 into I1.
I1.
V1 equal to H11 into I1. So H11 equal to
H11 is
V1 divided
V1 by
by I1.
I1.
Similarly, in the second equation, when the V2 equal to 0, then I2 equal to H21 into I1, and H21 is equal to I2 divided by
I2 by I1.
right? So if you observe these two
I1.
equations, the units for the H11 is what are the units for the H11?
Ohm.
It is ohm, because
Ohms.
it's in the voltage. Right? And whereas for the H21, so that is the
Constant.
no
No
unit.
unit.
units.
Current gain. So there is no unit for the
Current gain.
H2. Similarly, if you want to calculate H12 and H22, if you want to calculate H12 and H22, that means if you want to calculate H12 and H22, then you have to make I1 equal to 0. So I1 equal to 0 means you have to open the first.
Open circuit.
We have to open the first port. So we have to make I1 equal to 0. I1 equal to 0 means input current equal to 0. Input current equal to 0 is nothing but input port is open. Current 0 means it is the open circuit, and voltage 0 means it is the short circuit. So I1 equal to 0, so it is a open circuit. Which port will be open? Because I1 equal to 0, first port must be open. So now open the first port. If you open the first port, then I1 equal to 0, then how we calculate H12? H12 equal to when I1 equal to 0, then we have the V1 equal to H12 into V2. So H12 equal to V1 divided by
V2.
Similarly, H22 equal to I2
I2 by V2.
divided by V2. So if you observe H12 and H22, the unit for the H12, there is no unit for the H12 because both numerator and denominator the voltage parameter. So there is no unit for the H12. And whereas for H22, the numerator is the current and the denominator is the voltage. So its units are more. It's the current by the ratio between current and voltage. It is like a admittance. So admittance units are the most. Where voltage, if the ratio is voltage and current, it is the impedance. Then the units are ohms like this. So this is the procedure for calculating the hybrid parameters of the any two-port network. That means if you want to calculate the hybrid parameters of any two-port network, hybrid parameters means H11, H12, H21, and H22. So first, try to short circuit the second port or make the V2 equal to 0. If you make V2 equal to 0, then we are able to calculate H11 and H21 by taking the ratio between V1 and I1 and by taking the ratio between the I2 and I1. And similarly, if you open the first port, and that means if make the current equal to 0, I1 equal to 0. When you make the I1 equal to 0 by opening the first port, then you are able to calculate the H12 and H22 by taking the ratio between the V1 and V2, and also by taking the ratio between the I2 and V2. So this is the procedure for calculating the hybrid parameters of the any given two-port network. So this is the procedure. So these steps are unique for finding the H parameters of any type of the two-port network. This is the procedure for calculating the H parameters of the any two-port network. Now, see. So what we discussed till now, all the values are summarized here from the equation number 21 to 24. So we are able to calculate the H11 and H21 by making the V2 equal to 0 and taking the ratio by making the V2 equal to 0 and by taking the ratio between V1 and I1 and I2 and I1 respectively. So making V2 equal to 0 means you have to short circuit the second port. Similarly, we are able to calculate the H12 and H22 by making the I1 equal to 0, by making the I1 equal to 0. That means by opening the first port. And open the first port and make the I1 equal to 0 and take the ratio between V1 and V2 for calculating the H12 and take the ratio between I2 and V2 for calculating the H22. So this is the summary for calculate the hybrid parameters or H parameters of any given two-port network. Now, we will discuss one problem for the same circuit, and we are trying to calculate the hybrid parameters. Now we are trying to calculate the hybrid parameters. So same circuit I am considered for calculating the hybrid parameters, right? Done. Right. So for this two-port network which is available on the screen, so now I want to calculate the hybrid parameters. So first I want to calculate H11 and H21. First I want to calculate H11 and H21. If I want to calculate the H11 and H21, what I have to do? So we have to make
Short circuit
equal to
second
0, right? That means short circuit second port. Now short circuit the second port. Now short circuit the second port, right? So short circuit the second port. Now I am short circuiting the second port. Right. So after short circuiting the second port, how we calculate H11? H11 equal to the ratio between V1 and I1, right? The ratio between V1 and I1. And how we calculate the H21? That is the ratio between the I2 and I1, right? Right. Now, if we want to calculate H11 and H21, my aim is first I want to calculate the I2. So for calculating the I2, first of all I want to calculate the I1 now. So what is the value of I1? If you want to calculate the I1, so first of all I have to calculate the total resistance. So anyone can tell what is the equivalent resistance for the circuit?
4 ohms.
4 ohms.
15
Because there is a short circuit. There is a short circuit at the 50 ohm resistance. So neglect the 50 ohm resistance. Now we have the 5 ohm resistance and 20 ohm resistance which are in the parallel. So that's why there is a 20 R1 into R2. R1 into R2 means 20 into 5 divided by R1 plus R2, 25. So that's equal to 4 ohms. Now, once you get the 4 ohms, now what is the value of I1? How we calculate I1? So I1 equal to voltage by total resistance.
V1 by 4.
V1 by 4. V1 by 4. So we have the I1 value that's equal to V1 by 4. After getting the I1, what next we have to calculate? We need to calculate the I2 because I know I have the value of I1, but I know not the value of I2 if I want to calculate the H21. So I want to calculate the I2. So what is the value of I2? Same procedure which we did for the ABCD parameters. See, the total current I1 is splitted or it is flowing through. It is flowing through 20 ohm resistance and 20 ohm resistance and so 20 ohm resistance, and whereas a remaining current is flowing through. The remaining current is flowing through 5 ohm resistance and through the short circuit and feedback to the input port. Because no current is flowing through the 50 ohm resistance because due to the short circuit occur the 50 ohm resistance. So the current flowing through the 5 ohm resistance is nothing but is opposite to the I2. So first calculate the current flowing through the 5 ohm resistance I5, that's equal to current flowing through the 5 ohm resistance I5 equal to total current I1 into opposite resistance 20
20
divided by
by
total resistance 25.
20
Right?
plus 5.
20 plus 5, that is the 25. That is the I5.
4 by 3 I1.
Now
0.25 I1.
I2 equal to minus I5, that's equal to minus 20
4 by
divided by 25, 20 divided by 25 into
I1.
20 into I1, right? Now, so now tell me what is the value of H11 by summarizing all the equations. What is the value of H11? H11 equal to V1 by I1. Na? Here I1 equal to V1 by 4. So V1 by I1 equal to V1 by I1 equal to H11. That's equal to what is the value? Ma?
4 ohms.
Yes, 4 ohms. Because it's the ratio between the voltage and current, so it is the 4 ohms. And next H21. So H21 equal to I2 by I1, right? I2 by I1. Now come to this equation.
4 by 5.
I2 equal to minus 20 divided
Minus
by
4
25
by
into
5.
I1. So I2 by I1 equal to minus 20 by 25. And minus 20 by 25. That's nothing but minus 0.8. Right? It is the minus 0.8. Right. So this is the how we calculate the H11 and H21 for the given two-port network. Similarly, we will try to calculate the remaining two parameters. Those are H12 and H22. Now we need to calculate the remaining two parameters H12 and H22. So how we calculate the H12 and H22? Now we will discuss. So we calculate the H12. H12 equal H12 and I want to calculate H12 and H22. If we want to calculate the H12 and H22, we have to make I1 equal to 0 is nothing but I1 equal to nothing but first
Open circuit first port.
port open. First port open. Right? First port open. Now give me some time. So okay, so first port must be open. That means the first port, this is open, then I1 equal to 0. Now feed the voltage at the second port, V2, then the current is I2. Now tell me, so if it is open, then I1 equal to 0. And if you want to calculate H12, what is the formula H12? That's equal to, H12, that's equal to,
V1 by V2.
V1 by V2.
right? V1 divided by V2 and H22, that's it. Okay.
I2 by V2.
Fast. H22, that's equal to I2 divided by V2, right? I2 divided by V2.
V2.
Right. So if the I1 is 0, first port is open, I1 is 0. When the I1 is 0, now what is the equivalent resistance when we seen from the second port? What is the equivalent resistance when we seen from the second port? Second port మనం చూస్తే what will be the equivalent resistance? ఎవరైనా చెప్పగలరమ్మా? What is the equivalent resistance if you seen from the second port? Because it's open now. If it is open, 5 and 20 ohm resistance are in series. And net resistance is in parallel with the 15 ohm resistance, right?
Parallel.
Right.
15 into 25 by 15 plus 1.
20 plus 5 because 20 and 5 ohm resistance are in series and net resistance is in parallel with the 15 ohm. So that's value equal to that value equal to 25 into 15 divided by 40. 25 plus 15, that's equal
9.375.
9.375. Good, thank you. 9.375. Okay, na? That's the equivalent resistance. Now, what is the value of I2? So I2 equal to V2 divided by equivalent resistance. So that nothing but I2 equal to V2 divided by 9.375. I2 equal to V2 divided by 9.375. Good. So from this equation, I2 equal to V2 by 9.375, we are able to calculate the H22, right? We are able to calculate the H22, right? So what is the value of H22? H22 equal to I2 by V2 and I2 equal to V2 by 9.375. So H22 equal to I2 divided by V2, that's equal to 1 divided by 9.375. Is it okay, Nama? Mos. Right? And similarly, now H22 is calculated. Now I want to calculate H12. If I want to calculate the H12, I want to calculate the V1. So V1 is nothing but the voltage at the first port. So voltage at the first port is nothing but the voltage at the 20 ohm resistance. So if you want to calculate the voltage at the 20 ohm resistance, first of all you have to calculate the current flowing through the 20 ohm resistance, right? So what is the value of the current flowing through the 20 ohm resistance? I20. Current flowing through the 20 ohm resistance I20 equal to ఎవరైనా చెప్పగలరమ్మా what is the I20 current flowing through the 20 ohm resistance? See that this is the total. I2 is the total current, right? This total current is splitted through 15 ohm and remaining current is flowing through 5 ohm and remaining current is flowing through the 5 ohm and 20 ohm, right? So what is the value of I20? Average I20 equal to total current I2 opposite resistance 15 divided by 15 divided by 40, right? 20 plus 5 plus 15, that's a 40. So that is the I20. I20 is the current flowing through the 20 ohm resistance. But actually what I want, I want the V1 value. So V1 value equal to current flowing through the 20 ohm resistance, that is the I20 into the value of the resistance, that is the 20. So V1 that's equal to, what is the value of I20? I20 equal to I2 into 15 divided by 15 divided by 40. That is the I20 value, right? Into 20. See, V1 equal to current flowing through the 20 ohm resistance I20 into 20, where I20 value equal to I2 into 15 divided by 40 into 20. Now we need to calculate the H22, right? So H22 equal to H22. No. What you have to calculate? H22 already calculated, right?
H12.
We need to calculate H12. Sorry, we need to calculate H12, right? So H12 that's equal to V1 divided by V2. So, but we have the V1 expression in terms of I2, not in terms of V2. Then what we have to do? We have to find the value of I2 in terms of V2. So can I write V1 equal to, ఇక్కడ చూడమ్మా ఈ equation I2 equal to V2 divided by 9.375 ఉంది కదా. So just replace this I2 value here. Then what we have? So we have V2 divided by 9.375. V2 divided by 9.375, that is the I2, into 15 divided by 40 into 20, right? Now tell me what is the final answer? H12 equal to V1 by V2 and V1 equal to V2 into something. So V1 by V2. So finally H12 that's equal to, H12 equal to
0.8.
equal to
0.8.
0.8, amma. So that's nothing but
Yes, sir.
1 divided by 9.375 into 15 divided by 40 and into 20, right? Okay, na? So that's value equal to
0.8.
Right, 0.8. Sorry, it's okay. 0.8. So there is no units for calculating the H12, right? So this is the procedure how we calculated the hybrid parameters of any given two-port network, right? So the procedure is same. What the procedure we applied for calculating the hybrid parameters of the given two-port network. Same procedure we can apply for the any type of the two-port network. So first try to calculate the H11 and H21 by making the V2 equal to 0 or short circuit the second port. And later calculate the H12 and H22 by making I1 equal to 0 or for opening the first port. So we can calculate the H12 and H22 by taking the ratio between V1 and V2 and I1 and I1 and V2. Similarly, we are able to calculate the H11 and H21 by taking the ratio between V1 and I1 and I2 and I1. So this is procedure is same. So whatever may be the circuit, but you have to follow the same procedure. Okay, now? So we have only 3 more minutes, so it will close automatically. So because our 40 minutes time also completed. So tomorrow we will discuss. So till now we discussed how we calculate the Z parameters, how we calculate the Y parameters, transline parameters, and also H parameters of any given two-port network. Okay. So I take the only small circuit and I explained how we calculate all these parameters. But it's better you practice with the more number of circuits and try to calculate all the parameters for each circuit. If you do the more practice, then you will be because we don't know which type of circuit will come into the examination. That's why the more practice is required for the electrical circuit. And tomorrow we will discuss about the interrelation between the various types of the two-port network parameters, interrelation between the various types of the two-port network parameters, like how we relate the Z parameters in terms of the Y parameters, how we relate the Y parameters in terms of the Z parameters, how we relate the transline parameters in terms of the Z and Y parameters, like that. The interrelation between the different type of the two-port network parameters we will discuss in the tomorrow's class. Okay, Naman? Okay. So my request is because we can't do more number of problems with this online sessions. So that's why I'm requesting you try to solve multiple number of problems. You can choose any type of the text, take one circuit, and further circuit try to calculate the different type of all the parameters, so all Z, Y parameter, H parameter, and H parameter. If you have any doubt for solving those parameters, so just you can WhatsApp me or you can call me. I will clarify if you have any doubts for solving these parameters. However, try to understand the concept. No need to by heart the problems. If you understand the concept, it is easy for you to calculate the parameters of any given two-port network. Anyhow, in the tomorrow session, next 2 days, we are going to discuss about the interrelation between the various types of the parameters, and later we are going to discuss about the if there any two-port networks, any two-port networks are connected in cascade, or the two-port networks connected in series, if the two-port networks are connected in parallel, then how we calculate the all these two-port network parameters we are going to discuss in the coming classes. So we will close this session for today, and we will meet tomorrow at 4:50. Okay, ma?
Okay, sir.
Yeah, thank you.
Thank you, sir.
Thank you, sir.